Very good. Let's go ahead and get ourselves started today. Today we are kind of continuing with Module 5. A little bit unusual as our pattern goes, but you have a little extra time for Module 5. And we want to just kind of check in and see how things are going. We're kind of on a workflow that starts with kind of creating some building forms that we're flexing, first creating a building form that can be flexed, and then doing some flexing and sort of seeing what kind of values we can easily report out of it. And this will roll forward into some different ways we'd like to evaluate that building form, how we could sort of think about whether it's good or bad, or not usually bad, but some forms are better than others. And we're going to think about what we think makes some forms better than others as Module 6. Okay. And then ultimately in Module 7, we're going to learn how to use a tool that'll let us plug all this kind of infrastructure and modeling into place, and it'll automate the generation of a lot of alternatives, putting out and graphing of some of the results so that we can try to figure out what some of the optimal or some of the better places are to be searching as opposed to others. Okay, so that's kind of where we are in the high level scheme of things. So in there, give that a try. No worries. And why don't you go and slide the trash can in there? Perfect. So can I keep it going? There we go. Excellent. Okay, so in this, we have this whole notion of defining these building forms, as well as then just kind of manipulating these building forms so we can flex them. And what I'd really like today to be more than anything is just sort of addressing some problems you guys are having or sort of struggling with, and just would like some help with, because there's some basic stuff laid out in the examples, but it's almost more interesting to kind of think about some specific problems and how you go about debugging those problems, because when you work, that's nice, but often when they don't work, you need to know how to go ahead and address that and like how to approach things. So I'd probably start with this whole issue of really just defining the building forms and kind of focus on that as a starting point. Then we can talk about this whole issue of how you flex the form and use the infrastructure to kind of vary different input values and stuff like that. So as we start with that whole notion of just the building form, does anyone would like to suggest? I could kind of look at some different examples of that, but if you guys have an example that is creating some difficulties or creating some interesting problems, I'd love to look at that too. So does anyone have a building form or a building family that they're struggling with? No, yes, Daniel, what do you recommend?
So I was looking at using like the twisting cog tower.
Yes.
And I was having a little bit of trouble with like maybe a constraint with the base outer radius for that form. Like it seems to be like I can't go over 100 feet, and I can't figure out why.
Sure. Okay, so the question is on one of the different forms, and one of the ones that's in the folder is this thing called a twisting cog. How do we start thinking about the outer limits of what that form can be? Because there definitely get to be points where, depending on how you've modeled it and set up the constraints, you can violating things and creating geometry that just cannot be formed. And then Revit just starts complaining at you because it says basically, hey, I don't know how to create this thing. So maybe that's a good starting point. Let's go ahead and take a look at that. So in the scheme then, let me go to Revit and we'll start there. Okay, so we're going to go into Revit, and there's going to be a couple of different things happening here that sometimes create some confusion. There's the for families, okay, and then how you use them in Revit. And that's actually a stumbling block. I've seen a couple of questions about that. So that could, again, be something we just want to think about. So we're opening a Revit project. Okay, that's the environment where we're actually going to be doing some flexing. I'm just going to create a new one. Again, this is going to be kind of unimportant for now. Later on, it's going to be important where we put this in the world and some of those things, but for now it's just sort of a relatively abstract space. Okay, and then we're also going to go ahead and open a family. Okay, and the key is to make this work, we're going to open a family, we're going to define and kind of tweak that family, how it's sort of created, what sort of parameters are available, and then we're going to put it into a project. I know that's been a stumbling block for some people, is that working in this family environment, and what's the difference between the project environment? Okay, so what I'm going to do is also open, let me pop back out there. Hang on, I'm going to cancel this just so you can sort of see it a little bit better. I'm going to say open a family as opposed to a model being the project file. And when I say open that family, let's go ahead and I'll see if I can find where these things live. CEE 120C, 220C library is a place. I think it's over there. And I have some custom towers in here. Parametric tower forms. Okay, let's see if I can find a little twisting cog. There it is. Okay, and this one actually came from like a student several years ago. This was their idea of how to do something like this. So we'll update the family. At a really high level, this is now in the family editor, and this thing is actually defined by 3 different profiles. So let me zoom on in here a little bit, and you can sort of this thing, it almost looks like a little hazardous bio something or other sign or something like that, but it's basically a couple of concentric circles and then pieces of it missing. Okay, and that's kind of a profile. Now, to use this, just to kind of rush it a little bit, we're going to okay, notice that it says that it's enabled show mass mode. The reason is the mass family doesn't typically show. So some people were asking, oh, well, I can't really see what's going on, or Revit's complaining that things aren't visible. Okay. I'll drop it in there right now. Go to 3D. And the issue is really whether or not you can see masses or not. Did because it sort of realized I was doing something with a mass and nothing else, is it turned on this thing called show mass mode. Okay, and I can either see the mass or not see the mass. Okay, but in general, you'll need to see the mass in order to kind of like make sense of it. And in a little bit, we're going to go through and kind of divide that into some floors that we can report on. But for now, let's kind of just focus on this family itself and really how it's defined. Okay, so if I look at that guy, okay, oh, I can do many things. I'm going to dissolve that form for just a minute. That's just sort of basically undoing the form, getting back to the root profiles behind it. And there's the 3 profiles, and you actually see it's sort of the same profile. There's this profile called cog, and what's happening is this profile is placed on 3 different planes, lower, a middle, and an upper plane. The degree of rotation to that. Now, this template that lets you kind of take these profiles and just drop them on a plane and twist, we gave to you, and you're welcome to kind of keep on using that. It's pretty easy to go ahead and set up the heights. The whole thing with the twists just involves a lot of very finicky little messing around, which is why I give you the template to work with, because it's easier just to take the template and just say, I want to change the profile to a different profile than to place a new one, because that profile is. But as we think about this profile, and it doesn't really matter which one we want to look at, we can edit its family. Let's talk about what that is. Okay, so this mass family is a form, a lofted form in our language that connects the 3 different profiles. Or as you did in prior exercises, you lofted together 3 different curves, but it's kind of the same operation. And so this profile, we could draw the line here, but it's often easier to kind of create the profile as a separate series of curves and bring them in. Okay, and when I say edit that family, it gets back to this. Okay, and let's take a look at that in the plan view, because that might be easier to understand. Okay. There became this big old issue of how to go through and define this thing that looks like a cog. And back then, scheme for subdividing the curve into a certain number of segments, and I have these half angles but how many did I divide it into? It's basically 1, 2, 3. I guess I almost have it kind of like a clock, although it's not quite. It looks like there's a kind of a slightly different number of segments in there, but there's basically a whole series of different lines and points that are connecting them. Okay, and then these different angles ultimately determine the, and there is basically a profile that connects all those different points. So what's happening is I started with drawing these lines and had different sorts of constraints that would kind of keep them pivoting around the central point. You can see they're sort of arrayed around the central point. And then there's these intersections where we draw points. Okay, and then connecting those together, we sort of make this profile that joins them into this funny shape. So Daniel, what are you trying to do to the shape? So we can go 1, 2, 3, then I drop in 1, 2, 3, then I pop out 1, 2, 3. So what are you trying to do to it?
I'm trying to make basically like the base of it, or just make it larger past like 100.
Oh, okay. So what could be happening to you then, okay, if it's not changing the cog, if you're going to live with the basic cog shape, well, let's kind of see what's available in the cog. I don't even remember, it's been so long. So what do we have here? We have the half, just compute that, the half spread, the outer radius. Okay, it looks like this cog is really defined to give you like 3 cogs, yeah, independent of the radius. Okay, so if we're not going to edit that, we'll kind of live with the fact that it's going to be 3 even cogs. So we could play games and make it 4 or something like that. Let's come back out to here. That's the one. So as we take this, and I'll put these back together again, creating a form. Okay. The key to this thing is just to sort of play with the parameters here and see where it breaks. And where it typically is going to break is if you get some sort of geometry that folds in on itself. Okay, so it could be by twist or it could be by radius, but we'll get to some geometry that just won't work. So for example, okay, and you want to get to like 100 or something like that, or 120?
It seemed like when I went past 100, it didn't work.
Sure. Let's try it. There's 90. 90 is kind of happy. Let's see what's happening here. 100. Okay. It's so far, again, always start manually, because if you can't do it manually, then it won't work in Revit. Let's go to 120. Ah, okay. So there's some limit in there. Okay, 120 seemed to break it. Maybe it is 100. 105. Interesting. Okay, so our question is really what is at 100? Okay, and let's kind of think about this. It could have something to do with this taper. My suspicion is, you see that kind of funny little area right in here? I think that there might be something where as it gets fatter at the bottom, okay, it may have this thing where those two things start pinching in on each other and connecting. But again, let's just sort of test this a little bit. Let's say the top rotation is 0, the middle rotation 0. And again, this is partially related to the rotations, because if the rotations get too far, again, things can kind of fold on each other. So let's see about that. Now, okay, it seems like it's just sort of broken right now. So let me cancel out of that. And again, see if we can kind of just tweak this a little bit. Let me do 0 there. Okay, let me do that. Let me do the mid rotation as 0. Okay, so this shape with no twist, I think may let us spread a little further. So let's see if that'll work. But again, I'm just experimenting to see where it breaks. Okay, doesn't like that. Let's try this. Let's say the mid radius was instead of 60. Let's try it more like 80. Not there. And well, there's the top. I'm just playing.
just picked a hard form to work.
Oh, it is. No, I think that's partly just sort of it, is that. Let me try this again. We're just trying to tweak in small ways. I think that basically this form and this height is just very sensitive in that there's not really, well, let's put this back again like this. Still back in there. Let's go back over here. It's not so unhappy about that. Let's get the top outer radius over here. Let's make it that same 80. It'd be like a skinny tower there. Okay, so I think you're just sort of getting this thing about really where the pinching happens and sort of a combination of whether it's rotation, mid height is right now, it's in the middle. Let me even pull it up higher. I think since it's straight up vertically, it might be better. Okay, now let me try making the base rotation go out a little further. Or the base outer radius. Nope. Pull that back in there. Okay. So the upshot of all this is it's nothing you're doing. It's really just that for this particular form and the way it's defined with those different curves sort of swooping on up, it's just, we got to be sort of careful about just really where that breakage point is. So I think that maybe, let's try this. Let me try the mid radius as being more like 100. See if I can make it kind of thick in the middle. Okay. And now we'll do the base out 100. Okay, and now 120. It just really hates that.
Yeah. I basically ran through the whole thing and like flexed it, and then I just couldn't make up the square footage requirement, so I wanted it.
No, I just got to dig back in there and sort of see what's wrong, in that. It's just, so in this case, there's something about the form itself that we need to tweak to go through and sort of see how we can, kind of do that. So you're doing everything right. It's just, that's a very fussy form where the more the twisted triangle and stuff like that, they're a little more resilient to twisting and contorting. Okay. No worries. Okay. Other questions about forms? Any sort of big form questions? Forms are you guys working with? Did you make your own, or are you thinking about how to make a form, or like what are we sort of thinking about? Are we still getting started and we're just kind of considering what to use right now? Any ideas? Let me open up another one. Oh, hang on. I'll go back to the 120C. Forms. And again, you can do it this way. Another way, actually, any of us to consider is we could do this just using the dynamo curve definitions. And if you do it that way, it still comes down to, can it be lofted together? But I think sometimes that has a little more resilience to it. So if, for example, should I have a template? There's my template right now. So let me pop this back. So again, you can sort of see it because it's really kind of whatever you want to work with. Okay, you can see these are these big flying chevron shapes. I can dissolve those if I want to, so I can actually see them. So you get into sort of seeing what these different kind of profiles are. So this flying chevron profile, it looks like I have distance parameters. Okay, 200 and 300. So if I open that family, you can sort of see this is what the shape is defined as. So this one's a little bit easier because it only has the 4 points. So we have the center point right there, I have a length and a width, and then I take those different points and just kind of spread it around. If, for example, I wanted to have this shape, but I wanted to go through and, have a point out here, and then control that to be more like a diamond shape or something like that, that would actually also be a valid profile. So for example, maybe in this world, if that's the center, I could say, what I'm trying to do is just stretch those. What do you want to stretch? Right, so you're pinned. I'm trying to basically just pull that one up here, pull that one up here. Okay, that might be my diamond shape profile, though it's be better if it's actually locked right to the corner there. Okay, the thing to test in all this stuff is if I change the parameters, just let me come over here. So it's 100 by 400. I'll give that a little test. What if it were 200? Okay, you can see that it didn't quite stick in terms of what's going on right now. So we should again try to fix that. Actually, let me do it this way. There we go. That silly thing is right on the tail end of there, so it's not letting me pull. What I want to do is back over here is just basically put a point. When I put a point right there and it gives me the little intersection there, that means it's sticking to the intersection. Okay, when I put a point down here and it's sticking to the intersection, and then this one, okay, looks like it's inferring the intersection. Okay, let's try this again. And you saw that wasn't very reliable. So instead, I'm going to try placing new points. No, thank you. Okay, try that. So again, we'll flex this. Ah, looks a little bit better. Try bringing that in. Okay, so this profile seems to be responding properly to the parameters. Okay, so if we like that profile, super. Let me save it as away. I'll say that we'll save this as a family. And I'll put it out there in that library. Actually, I think I even have a folder full of profiles in there somewhere. There they are. Okay, so now that I have that diamond profile, if I can get that to behave nicely, what I can do is load it into my 3-profile template. Okay, and it'll be available for me to use just in the tower. So if I come over and I say that up here, I want to use instead, okay, that should be okay. Now, my theory is, let's try this again. I'll put the diamond down here too. Since I got 4 points going to 4 points, I think it ought to be able to make this tower. Where it usually gets in trouble is when you have uneven numbers of points and it has to kind of do some really weird geometry matching. But I think this will actually work. Again, it's all an experiment, so don't. Okay, so that now is kind of a diamond slash, like, you know, whatever. And again, if we wanted to go through and change that profile, we could change that. And now that did a lot of weird twisting that, of course, you think is going to probably break things. So I would probably dissolve it and reform it based on that before I went back in there. Yeah, Daniel, what you thinking?
I guess like, so you said that you have an odd number of points where it doesn't just like crap out automatically. It would try to make.
It'll try to do it. So the classic thing is people try to take round shapes and you sort of try to loft them together with like a triangle shape or something like that. And what it'll usually do is it'll try to do its best to collapse the points. But as you say, it might crap out at some point. And the best way is, though, again, here, okay, before you actually take it into Dynamo, because you'll find it's almost like with the twisting cog. Your debugging strategy is, okay, Dynamo's not doing it. What's going on here? So let's go back and try to do it manually. And if it's still crapping out there, then you know that, okay, there's just something, because it'll only do what it can do. So it's often easier to debug by going back to the root source. Okay. Can you have what? Two?
When you like attach 2 points on the base to the same points in the middle.
It'll just sort of depend. It'll try to do it, but it's a little unclear what it'll do. So for example, these are both 4-point profiles. Let me try going for an uneven number here. Well, here's like the triangle profile. Okay, so that's what happens if 4 go to 3. Okay, and let's see what it actually did. It's a little hard to tell. I'm in 3D over there. Hang on, I'm looking at the wrong thing. Okay, that came to there. That came to there. It's a little weird over here. Oh, see what it did? It converged 2 points to 1 point. So it'll do its best to make sense. We're quite sure. So the best strategy is to have the same number of edges, rather either curved edges or straight edges between the different levels, because then it'll have an easier or a more predictable result. Okay, it's just, whatever it does with the math, and it's not quite sure what to do. So it makes an assumption and you hope it does it, but sometimes I've seen cases where it doesn't resolve. Okay. As you think about this whole assignment, the idea of kind of coming up with some interesting tower profiles is part of it. It's really just to get the experience of trying to create something, a form that you can flex and all that type of stuff. But in the end, if you end up with a relatively simple profile, I have some triangles that round up, if you have some squares that twist, if you have, pentagon, whatever, keep it simple, because it's one of those things in all the layers of complexity of what, there's all these beautiful forms that we'd like to make for our ultimate design, but as we're learning, it might be better just to kind of keep a relatively simple form, with the idea that if we had a reliable form that was more complex, we could swap that in. Okay, but for our purposes, no one's going to evaluate you as, oh, your form was too simple. It's okay, make sense? Okay, so has this whole issue of form, doing it with just doing the profiles in Dynamo as opposed to doing them in Revit, because that's a valid path too. Okay, can go either way there. Some of our friends who are doing this in Grasshopper need to do it in defining the curves mathematically as opposed to doing them in Revit. And again, there's a small trade-off there. There's sort of a speed advantage to doing it just mathematically in Dynamo. The disadvantage is you can't easily just say, oh, give me the floor area. You have to kind of have a special series of nodes that compute the floor area for you. But the tail end is that it happens much faster. So, in the longer run, like generally being able to define these things as Dynamo shapes as opposed to Revit shapes is probably a pretty good thing for like moving ahead and give yourself a lot of flexibility. Okay, so good on that. Okay, that's the whole first part of the exercise there. Okay, let's go to the tail end, then we'll go to the part in the middle. Let's just kind of look at again what you're asked to do so that we have clarity on that. And then we'll talk about how you manipulate these shapes. So the idea here in the assignment, let's just take a look at that, is that you're going to set up a building model, okay, using one of our examples. Okay, that's really easy. Okay, build the Dynamo graph logic to flex one of the form's parameters. Okay, and there's some good examples for doing that. Then report the metrics for 6 alternative design scenarios. So if you're flexing one metric, that would be, say, 6 different heights or 6 different twists or 6 different widths. Okay, but the idea is you're really just trying to get the experience of putting a form in, kind of setting up the logic to twist so that you can report that into like a nice Excel table or something like that. Super. And the good news is there's examples that kind of show you most of how that works, just right in the Canvas examples. Let me find that again in there. Where'd they go? I can't find anything. Where'd you go? Google? No, no, no. Did I close Canvas? What's over there? Get very confused about how Chrome opens multiple windows, and I need to get them to collapse on a single tab. Okay, so if you come down to flexing a single input variable and then ultimately reporting the tested alternatives, you know, that really has most of what you want. Okay, let me open that example. Well, now let me talk about the second one, then we'll open that example and talk about where my examples go wrong, because some of you have discovered where they go wrong and you need to know how to. Okay. For 3 or 4 units, it's a little different. You want to kind of create your own building form. Again, doesn't have to be incredibly complex, but kind of come up with something a little bit original. Okay, about what you'd like to see. Build the node logic for 2 parameters. Okay, so like height and width or whatever it is. And then we're going to think about the combinations of those. And we're going to use a very specific type of node that does what's called a Cartesian product, or like a cross product, to deflect them both. But in the end, it sort of reports out kind of a single value. Okay. And then ultimately, again, we're just going to basically report the metrics. Okay. So, and the reason we're doing all this is we're reporting these simple metrics that are automatically computed. Next week, we're going to kind of define some new metrics. We're going to define some new formulas that will kind of compute some values. Okay. So let's go back over to the examples and just look at kind of how these are put together and where they might go wrong. So as I say, flexing a single input variable, let's kind of take a look at that example and really, again, where the holes are in that scenario. So when I generate some alternatives, flexing a single input variable, we'll start with that case. Okay, there's a couple of big things that are going on in the Dynamo graph that we need to sort of understand. We're going to come up with this notion of a custom node, and we're also going to hit the notion of a list map, which feeds values into this custom node. So let's take a look at that. I'm going to go to Dynamo. There's my tower. Again, I've loaded that tower in. It's not in the family now, it's in the Revit project, and I've divided it by 4. Question that came up was, oh, I can't find how to divide things into levels. If you're having trouble with that, it's probably because you're still in the family and you need me back in the project to do that. Okay, so as I look at this and I go up a level, single value. Okay, I'm just going to come in, oh, kind of right about in there. So let's take a look at what's going on over here. A lot of missing pieces. Look where that is. Okay. Basically, a couple different big things going on in here. These examples use this notion called a list map. A list map takes a list of values and feeds it through to some. So what it works on is like, it works like as a function where you have a node which has an open parameter, and then it'll feed those values into it. So at a really high level, I can select my model element right back there. Okay. Then I have these different things that are setting up just different parameters. In this case, it looks like I'm changing the height. Okay. So what I want to do is I've created heights here, 30, 40, 100, or 300, 400. There'll only be 2 values in there. In fact, I can run that and you'll see. I'm going to take that list of values. Okay. And I'm going to go through and compute something based on that. What I'm going to do is compute for this building form, these gross floor area, gross surface area. Okay. So I've even kind of named them over here. The only reason I name them parameter by name, so I just need to give it a name to figure out, tell it which parameter I want to get. So I'm going to give that one to report and that one to report. Okay, the parameter name to test, that's going to be used because we're going to say set a parameter by name. So I'm going to set the value of height. Okay, I'm going to give it a building form over here. Okay, so at this point, this node has one open value. Okay, so it thinks it's a function. And how it's going to figure out what to fill in is this list map is going to one at a time feed each of the values in the list in as that open node and then report out what the result is. Okay, so when I say that I'm going to link a result here, what I've just done is say, take 300 and plug it in right here, run the calculations and then give me the value, then take 400 and plug it in right here and give me the value. Okay, so at a high level, that's how list mapping works. It depends on a list of values that you plug in, okay, then a function that has an open node to it. Okay, now you may be wondering, well, okay, where did this function come from? Okay, and it works. You can edit this node. And let me even grab all these things here and show you where it came from. Okay, the essence of it is this stuff right here, transaction start, set the parameter name, transaction end. Okay, and in this case, we are taking in some parameter, we're setting the value based on the name you feed in. Okay, and then you're basically, that's the basic logic of what's going on in here. But let's talk about custom nodes for just a little bit here. Okay. I can go through and create any sorts of like nodes over here. 5. Okay, I'll say that's, I just want A plus B divided by C. It doesn't really matter what I put down here. 12. Okay, then I'll say that, oh, great, what do I want to do this? I'll do the math sign of that, pretending that's some sort of a degree value or something like that. Okay, and then I multiply that by 1,000. Super. And that would ultimately feed off to something else that's going to use that number. For right now, and watching is just going to give me something hanging around out there to feed it to. Okay. If this little blob of code here is so incredibly attractive that I'm going to reuse it a lot and stuff like that, I want to create a custom node out of it, here's all I have to do. If you can sort of think about it, okay, if I have those 3 nodes selected, what are the inputs? Yeah, it's the A, B on the left. What are the outputs? It's going over to the watch over there. Okay, so when I say create a custom node, this is how I created all my custom nodes. I just went through and said, let's go. Groups, delete, is under edit. I just have to find a way to find it. Create a custom node. Imagine that. Okay, we're going to give it a name. Okay, so this is going to be lens.junk. Okay, and I can put it in a category. I have some different categories. I actually have a 220C category we made a long time ago. Okay. It's going to basically create a new node. It's going to be called glens.junk. And glens.junk, whenever we use it, it's going to have these inputs and those outputs. Nope. What doesn't it like? It doesn't like the dot in there. Okay, well, be that way. Let's do like this. Stuff. Okay, we now have a custom node. If we open this custom node, let me edit that. You'll see that what it has done for us is it has defined the ABCs as inputs and it's defined that as an output. Okay, now we can give these all, it really doesn't really matter. This could be, you know, this is the first add-in, if I want to call it that. This is the second add-in. And this is the divisor. Again, there's nothing special about that. I'm just going ahead and giving them a name. The reason I'm giving them a name is that might make it useful for someone using the node to understand what I'm asking for. And this over here is my fantastic. Super. So if I go back over here, okay, it sort of looks like that. It's doing pretty good. Okay, so this would actually work, okay, in terms of being a custom node, and it should give us the result the same as though we had done it all kind of manually. The good news, though, is that this can then either be saved and reused between multiple projects, or we can use this node as a function in a list map. Okay, and that's what we're really after. Now, where should you put your custom node is always a good question, because when you create the custom node, the good news is Dynamo knows where it is, so it has no trouble finding it. Okay, however, when you come back later and you look for it, if it isn't in a location where it knows to look, it won't find it. So one of the classic things that people run into is if you grab the code, but you don't grab all the nodes that were the custom nodes that were in the same folder, it complains and says, oh, I couldn't find your custom node. Where is that thing? And the answer is usually you just need to go out to the library and grab it and then put it in the same folder as your stuff. So because of this, as you work from here on out, it's better to, as opposed to just leaving things on the desktop or just lying loose in documents, folder to put all that stuff in. So anytime you give us your project, you give us the folder containing everything. That'll make it just a little bit easier, again, to find everything. Okay, so I'm going to save this away. Okay, and I can put it somewhere. I'm not going to put it out there because if I put it out here in kind of the default library location, if I move between machines, it may not find it. So I'm going to instead see if I can go ahead and put it. I'm going to put it out in here somewhere. I'll make myself a new folder. Okay, and I'll call it this the class time example. I'm going to leave it called Glenn stuff in there. Okay, and in the same sense, I'm going to take this guy over here and I should save him into the same folder so that when I open him, it'll find them there. Okay. And I'll go back out to the last time example. Okay. Okay, so custom nodes. The big thing is define them, watch out for the inputs and the outputs. In general, it does a pretty good job of that, okay? But if you're not finding a custom node, it's basically that you have to come in the same folder. You'll find that I have a whole folder full of these things. Let's go back out to the 120C online library. There it is, okay? There's this whole thing about custom Dynamo nodes from the examples. So if you grab something and you just can't find the custom node, you might go to this folder because you'll probably find it hanging around out there, okay, by name. And then that should be, you can just copy it into your folder. So okay, now I like my little custom node so well over here. Okay, I can, oh, that's okay. Okay, I can just run it just this way and run it once. Fantastic value here for this one set of things. You'll see over here, this one gave me a couple different values for parameter 1, which was gross floor area. This one over here just gave me a single value because that's all I gave it right now. Okay, so the question is, if I wanted to test a couple of different values in here, if I wanted to say, hey, let's go ahead and do 3 to 10 by 1, something like that. So it'll be 3, 4, 5, 6, 7, 8, 9, 10. The truth is, this will probably work even without a list map. Let's see what happened. Because that's a pretty simple calculation, so it can understand how to handle it. If, on the other hand, we were going to take those values and feed them off to Revit to update the model one at a time, it wouldn't work because it would have to wait and pause and stop. So in that case, we would use a slightly different construct. We'd say list.map. Okay, and let's think about how this works. Where is the list? What is the list of values I want to feed in? And right here, that's the list. Okay, and what's the function? Okay. If I fed it in as a list, I have to disconnect it there because that's how it knows where to plug the value in. Okay, so this has the same effect. Okay, just feeding them one at a time. Cross your fingers, supposed to. Okay, so those values are all being fed in. And that's really the essence of running all this. It's just going, just using this list map and the function. So everything's just all about setting up the function to do what you want. And what we're even going to do is keep on just changing our functions to make them more and more complex. Yeah.
Oh, so it's only valid for one list.
Yes, well, yes, you can only feed in one thing at a time. So when we get to the feeding in 2 coordinates, you're going to find what we do is we take the 2 different values as a pair and we feed it the pair inside. So it can only pass a single thing, and the single thing you passed might be a list of 2 different things. Does that make sense? So you just have to pass it as a single unit and then you break it apart. And that's that next example. So let's go over there. The tail end of this, you guys pretty much got. You have this watch, you have the different values here. There's a little bit in here about how you get things out to an Excel sheet. So you can just pretty much borrow that chunk and it just works. Those are all. Okay, so to the very important question of, well, this kind of worked for 1. How's this going to work for 2? Okay, let's go over there. Combinations. And I'll start over here. Okay. We need to go ahead and create some combinations. So let me go ahead and I'll change that. I'll set that over there. Okay. We're going to join together 2 lists, and the 2 lists I'm going to join together are some height values and some rotation values. Okay. And this list Cartesian product will do that. So if I go ahead and run this, and I say Cartesian, let's see what it came up with. Okay. Bunch of little pairs. Not too bad. It's crisscrossing them all. Now, the only problem with these pairs, you see there's like pairs, but they're inside of an outer list. Okay. And half of what we get in trouble with in Dynamo is the list at the right level of hierarchy. So we basically have to strip away the outer list and just get the pairs to all be kind of the highest level. So that's what this flatten is. So flattening 1, so we just have pairs, but they're not in that outer list. So we've removed this list number 4. So now we just have 3 levels as opposed to a 4th level. Okay, that's what flattening is doing. Okay, and that's just, it's kind of like when we did the quad points and we had to flatten the list because we were just trying to get all 4 points, the groups of points at the highest level. Okay, so that list is actually your list. Okay, now we get to our function over here. And what are we going to do with the function? Okay, we have the building element. Okay, parameter 1 to test. Looks like that was top height. Second one was top rotation. These are just names of what to report out. Okay, you notice there's one missing parameter. Okay, combinations to test. No worries, I'm ready to kind of plug that in. That so far seems kind of gets very similar to the other one. So what's the difference? We can only pass in a single thing. In our case, we're going to pass in groups of points, 2 at a time. Okay, so if we're going to pass in a group of 2 things, we're just going to need to do a little work, break those 2 things apart. So we're going to bring in the combinations. And if you give me a list of 2 things and I say, get element 0, that is the first thing. Get element 1 is the second thing. So I'm just breaking them apart there. I'm taking the first point and the second point, and then I'm feeding them. There's a lot of watches in here just to help us debug, but I'm setting the parameter by the first one, then I'm setting the parameter by setting the height by one, and setting the by the other. So it's all about, sometimes you have to package things up to get into V1, and then on the other side, you have to break them back apart again. So put them in an envelope and take them back out. Now, all this stuff down here, input list 0 and 1, that's actually just the code block way of saying exactly the same thing. So when I say input list element 0, that's the same as code block list get out of list 0. It's the same, just the same thing. So no difference there. But once you've broken them apart, okay, you set parameter name, and then you twist the object. It does what it is. Now, in the same sense, you're going to learn that we have these 2 different values we might want to get out. We want to get gross floor area. We might want to get gross surface area. You might notice that you can only pass one at the same time. So we're going to use the same strategy. If we want to get both the things out, okay, what we have to do, and there's another example that'll show it, is do this. We can say list.create. Okay, take that item and take that item. Okay, that's going to make a little list of the 2 items. Okay, and then I'm going to make an output, which is the combined values. Okay, so now if I come back over to, where is it? This one. Okay, now we have combined values there. So if I wanted to pull this as opposed to just a single value, I would pull that as the output. Okay, and that would give me both. Okay, and you'll see in that last example in the little section, it kind of goes through how you combine them together, kind of, you know, 2 or 3 different values in a short little list. And then that will make different columns in your Excel table. So let's kind of pause there for today, because that is really the gist of what you need. And hopefully that gives you a little bit more about how these custom nodes, but it's sort of clear. How you feeling overall about your task ahead for this week? You sort of get a sense of it? Yeah. Okay, that's good. Okay, then let's go ahead and pause there for today. We're going to stick around and do some problem solving. Okay, but I have a couple meetings first, but if you want to hang around, we can help solve some problems or something like that. But we got a couple people I've promised some time to in advance, but let's just do that. And I'm just here basically till like 6:30 tonight or something like that. So if you have another class back later, you can do that too. Something like that. Kind of make sense? Okay, let us then adjourn for today. Good luck with it all. And if you need help, go ahead and again, start with your debugging, see how far you can get. And I always go start with the left, figure out the first thing that shows nulls, and see if you can figure out why that's giving an unexpected result. Don't even worry about what's on the right, because if it's wrong on the left, it's just going to pass down wrong all the way to the right. So go. And if you want some help, go ahead and if you can, if you can phrase your question in a way that is generalizable, because a lot of people have the same problems, okay, and put it in Slack that way, that's super, and then upload your files, okay, to ACC. That gives Daniel and I a good chance to, just try and give you some help. We'll try to point you to how to do it, and we're going to try and basically help you understand how you can debug it yourself. We're going to try and empower you that way. If we don't give you a direct answer, don't get frustrated with us, because we're going to take you right up to the edge, but let you go that final step, because it's often good to learn how to do that on your own. Okay, make sense? Okay, beauty. Let us go ahead then and adjourn for today.